So for our chime project, we decided that a circular pattern of hanging chimes would be the ideal solution to play all 12 notes of our chime song in a concise and even distribution. The way that we decided to accomplish this was by using 2 tracks on the outside of our chimes hanging circle. Our 2 tracks have our 4 solenoids mounted on the two tracks, 3 solenoids being on the bottom track and 1 solenoid being on the top track. The bottom track of the two containing the solenoids is tracked by a potentiometer, which is monitored through the code. And this allows for the solenoids to play the chimes accurately and consistently as it travels through the song, as the bottom track is allowed to rotate around the chimes and access all 12 notes as they're needed in the song. These 2 tracks are independently controlled, one by each motor, which are accessed using 2 spur gear systems to allow for enough range of motion to cover the entire span that the solenoids we need to cover on the chime circle.
We started with 5 different ideas for how we imagined our chime project to look like, and from there we used a Pew method to decide on our first iteration of the chime project, which was 3 solenoid tracks, pillar in the middle. From there, we came across our first change, which was changing the thing from 3 solenoid tracks to 2 solenoid tracks.
This was done initially because we thought that we were able to use all 3 of the motors that were provided to us, as well as all the other components like the solenoids and the potentiometer. But the requirements show that the control box that we were given can only power 2 of the motors, so that kind of limited the things that we could do.
The second change that we did end up making was shortening the entire structure due to size restrictions that we had to follow, which also meant shortening our chimes by an entire octave.
So another change that we had to make to our design was our 2 solenoid tracks. We initially wanted to 3D print this whole thing because that would minimize the amount of friction between the track and the actual static structure. And on Onshape, it said that the 3D printed tracks would be 50 grams total, or around 50 grams, not exactly 50, which would meet our 50 gram limit. However, when we printed these out, they were around 170 grams total, which would be over the limit. So we had to change up the way we would do our track. We instead decided to cut our track in half, with one top being out of plywood, like laser cut plywood, and the bottom would be 3D printed.
For the code, we first initialize all the variables and set up the pins. We then move on to a for loop, which will constantly call all the user-defined functions that essentially performs 2 main actions. Move the motor and activate the solenoids at the right time. We do this by using a non-blocking approach, which allows us to perform a lot of time-sensitive tasks at the same time without delaying the code or compromising the actions.
If we were to make improvements to our design, we would make a more rigid mounting structure for our chimes instead of using individual string. Doing this will make tensioning the strings way easier and less tedious than it was for our actual project. Along with that, we would also want to make our chime machine code more modular so that any song that uses those 12 notes that we played can also be played on our chime machine.